Good evening, ladies and gentlemen. Welcome to this, our first talk of 2021, and our second talk delivered through the medium of Microsoft Teams. I'm indebted, as always, to Nigel Wright, who's acting as the producer. He's had to learn by himself. There was no training involved. Shows you how versatile he is. I'm most grateful to Ross Priday for giving us his valuable time and an insight into the support of the Hawke, an aircraft that first flew in 1974 and entered service with the Royal Air Force in 1976 and is expected to remain in service until 2035, when it will have been in service for some 60 years. Amazing. Without further ado, Ross, over to you.
Okay, thank you, David. Good evening, everybody. Welcome to the first Oxford branch talk of 2021, and thank you to those who've joined. And thanks to the Oxford branch members who've been working hard to keep the lectures running virtually during the difficult times that we're all living through at the moment. So this evening I'm going to talk about the challenges that we face keeping the Hawke T1 aircraft flying safely as it approaches its 50th birthday this decade. I'll briefly cover the history of the Hawke aircraft. I'll talk about how the RAF and the Royal Navy currently use the aircraft in service and the extensive modification programs that are underway to keep it flying into the future. I'll talk through some of the ageing aircraft challenges that we face, some of the problems we found on the aircraft, and what we might be able to do to fix them. Finally, I'll talk about what the future may hold for the Hawke T1, and I'll explain why the decisions that are made over the next few months are crucial for the long-term future of the aircraft. Before we get into the detail of the presentation, let me briefly explain my own background and why I'm talking to you all this evening. So I joined the RAF when I was 18, and over the years I've been lucky enough to work on a wide variety of aircraft in many different countries around the world, including C-130 Hercules in the former Yugoslavia, Nimrod in Iraq, and Tornado GR4 in Afghanistan. I've also spent some time working on TriStar and Typhoon aircraft. In 2010, much to my surprise, I was offered the role of Chief Engineer with the RAeS, and that's what I did for almost 3 years until mid-2013. From there, I was promoted to be the Deputy Type Airworthiness Authority for the Hawke T1 and T2 aircraft fleets, where I had responsibility for the equipment safety and reliability for all the RAF and Royal Navy Hawke aircraft. I left the RAF in 2015 and have worked as an independent safety consultant since then, with a period of time spent as Business Development Manager for Bain Simmons. I'm currently a Senior Engineer with Nova Systems in Bristol, but I'm also the Aeronautical Director for GMR Aviation Consulting, which is a dispute resolution and accident investigation service for aviation legal matters. I also act as Chairman and Non-Executive Director for Cura Human Factors, where I get involved with organisational safety and human performance projects in aviation, but also in industries like construction and the health service. Anyway, that's enough about my background. Let's talk about the history of the Hawke aircraft. Well, back in the early 1960s, the Royal Air Force was mainly operating 2 jet trainer aircraft, as I'm sure most of you know. The Hawker Hunter T7, which was a 2-seat side-by-side trainer, and the Folland Nat T1, which was the mount of the Red Arrows from 1964 until 1979. In 1964, the RAF released a draft requirement for a trainer to replace both the Hunter and the Nat. At this point, international politics played a big part, and the French were also interested in a new trainer to replace their old Lockheed T-33 T-Birds and the equally dated Dassault Mystère 4s. So a round of typically complicated, shall we say, Anglo-French negotiations followed. And these discussions led off in one direction to the Anglo-French Sept Jaguar aircraft. The Jaguar was originally conceived as a trainer, believe it or not, and light strike aircraft. Ultimately, the Jaguar became very much a competent strike fighter in its own right, but was simply too much aircraft for cadet training. Tandem seat Jaguars were built, but they were used for operational conversion, not flight instruction per se. Then in 1969, the British Ministry of Defence gave the ball another push by issuing a requirement for a tandem seat, single-engined, subsonic jet trainer with weapons capability and an unprecedented 6,000-hour fatigue life. This specification was open to international competition, and in October 1971, the Hawker Siddeley aircraft proposal was accepted. In these slides here, you can see some of the early concept work and designs that were being considered. Now, there were a lot of different feasibility studies in the late 60s and early 1970s. But in the final concept design, you can clearly see the Hawke recognisable. And this was accepted, as we said, in late 1971. And this led to a production contract early the next year for 176 trainers, with the first to be delivered in late 1976. The first Hawke T1 flew on the 21st of August 1974 with test pilot Duncan Simpson at the controls. Now, the Hawke is not merely a good-looking aircraft. It's agile, it handles well with clean, responsive controls. And I can confirm that it's easy and great fun to fly. It's capable of transonic speeds in a dive. Air tests that I've flown on typically achieve 0.96 to 0.98 Mach in a dive without any difficulty at all. But this apparently came as something of a surprise to its designers. And it also has good range and endurance. It's also economical to operate, but getting more expensive to maintain, as we'll see later on. The first Hawke T1 to be formally accepted by the RAF was delivered in November 1976, with the last delivered in March 1982. As might be expected, some deficiencies were uncovered after the Hawke went into service. Some faults, such as a nose wheel that swiveled poorly, were corrected in later development, and some economy measures, such as low-cost radios, proved unacceptable in practice and had to be upgraded later on. But by the time of the last delivery, the Hawke had become the BAE Hawke, since Hawker Siddeley had been absorbed into the British Aerospace Group in the spring of 1977. I've got a short video here, which is a bit of a promotional video for the Hawke at the time. So it's a little bit dated as a video, but it gives you a good idea of the background and development of the aircraft. So we talk about deliveries. The Hawke T1 entered service with a 20-year calendar life and a predicted safe fatigue life of 6,000 flying hours and 15,000 landings. In the late 1980s, some aircraft began to experience fatigue cracking in the wings and tailplane, and whilst the problems were confined to older aircraft, a wing replacement program was initiated in 1989 under Mod 999. The program was completed in 1995. And other than the three recently retired Kinetic-owned T Mark 1 aircraft based at Boscombe Down, all aircraft in the effective fleet now have post-Mod 999 wings fitted. From 1998, replacement tailplanes also began to be fitted under Mod 1830. The vast majority of aircraft in the active fleet now have the replacement tailplanes fitted. In the early 1990s, changes to defence requirements backed up by maturing evidence of the airframe's structural integrity led to the 1996 out-of-service date being extended to 2010. Accordingly, around 1995, in order to achieve the 2010 out-of-service date, the Hawke Support Authority at the time commissioned a formal life extension programme, or LEP, which sought to clear the aircraft for a life of 10,200 flying hours, 165 fatigue index, or FI, and 25,000 landings. And just an interesting comparison to the US Navy's Goshawk fleet here, which has now got a 45,000 hour flying hour life, and it's maintained on condition, so a very different philosophy, and that's now under the design organisation of Boeing rather than BAE. But interesting to compare the two philosophies and how far into the future the US Navy are planning to operate their T-45 Goshawk. But of course, Trigger's broom is probably very true for the Hawke. Pretty much all of it's been replaced over the years. So while we say the aircraft is approaching 50 years old, parts of it may be, other parts probably aren't. So it certainly is a bit of a Trigger's broom of an aircraft. But to extend the OSD out to 2010, the Hawke Authority introduced Mod 2010 to replace the centre and rear fuselages with new items of a later design standard. And all the existing installations and equipment were transferred to the replacement centre and rear fuselages. And the programme ran from February 2000 to February 2003 and modified some 80 aircraft. Whilst most of the active fleet had been through the modification programme, a number of pre-Mod 2010 aircraft remained in service till quite recently. And they're not going to be aircraft that end up soldering on for another decade or so, but interesting to know that they were still around until fairly recently. With a current out of service date of somewhere in the region of 2027, possibly 2030, possibly going beyond 2030 to 2035 for some of the aircraft, to be decided, the Hawke T1 aircraft will theoretically be at least 54 years old, or possibly approaching 60 if it goes on to 2035, as David said at the start. So in total, 176 aircraft were delivered, as we said. A significant number have been written off or damaged beyond economical repair since entry to service. And between 1983 and 1986, 88 Hawke aircraft were modified to extend their role to include a limited air defence capability. Mod 680 made provision for the use of a Sidewinder air-to-air missile or a BL-755 freefall bomb on each of the wing pylons, although never actually been used in anger. Aircraft flying with RAeS incorporated modifications to the fuel system of the Jaguar engine, allowing a more rapid throttle response, as well as the carriage of a 70-gallon smoke pod on the fuselage centerline, containing separate tank compartments for diesel oil and red and blue dye. And as at the 1st of December 2015, when I left the service, 123 Hawke T-Mark1 aircraft remained in the departmental fleet, of which 57 were held in storage at RAF Shawbury, and these numbers will have reduced significantly over the past 5 years. For the fleet that's still in service, the Hawke T1 is currently used as follows. So for RAeS, they operate from RAF Scampton, as I'm sure you're all very well aware. RAF Leeming operates the T1 in the aggressor training role and to supply exercise and training support with the 100 Squadron, including support to the Joint Forward Air Control Training and Standardisation Unit, or JFACTSU. Royal Naval Air Station Culdrose operates the T-Mark1 in the maritime aggressor training and attack simulation role, and to supply exercise and training support with 736 Naval Air Squadron, formerly the Fleet Requirements and Air Direction Unit, or FRAeS. The RAF Centre for Aviation Medicine, or RAFCAM, operates the T-Mark1 at Boscombe Down for trials activities, clinical referrals and high G training. So that brings us up to date with fleet disposition, history and usage. Now, while the Hawke aircraft has been subject to carefully managed maintenance over the last 45 years or so to address the known issues, there is still a requirement under Military Airworthiness Authority regulations, and specifically RA 5723, to undertake an independent ageing aircraft audit. And that's an audit of the Hawke support team, or delivery team, as they're called these days, and the airworthiness and integrity management procedures and the physical condition of the aircraft itself. It's important to note that the audit is not just an activity on the physical aircraft, but it focuses very closely on processes within the camos and delivery teams, the qualifications of individuals who have delegated airworthiness authority, the effectiveness of meetings, the accuracy of documentation, and logistics information systems, and so on. The purpose of the ageing aircraft audit is to ensure that age-related problems have been identified, predicted where possible, and mitigated prior to their having a major impact on airworthiness, safety, capability, or cost of ownership, thereby providing assurance that the platform can continue to operate without an increase in risk to the platform or individuals operating it. The ageing aircraft audit, as outlined in the regulatory procedure here, shall be undertaken by a contracted organisation with suitably qualified and experienced persons. That has to be independent of the Hawke delivery team, the continuing airworthiness management organisations or CAMOs, the design organisations and other maintenance organisations. So it's an independent audit that needs to take place. And the most recent AAA, if we call it that, on the Hawke T1 comprised of 3 basic groups of activity as follows. Firstly, the Hawke delivery team undertook scoping of the AAA using the RA as guidance. But it's very much up to the Hawke TAA to decide on the breadth and depth of the audit. Secondly, the chosen AAA contractor undertakes the AAA itself and zonal hazard analysis tasks. So as we said, the AAA tasks themselves will comprise of process and procedural audits of the Hawke delivery team management systems, a physical condition survey of a number of aircraft, and the compilation of a final AAA report. The zonal hazard analysis will consider physical proximity, component system interaction, inadvertent operation effects, environment, and danger to personnel. And then thirdly, the TAA undertakes follow-up action, which for a typical AAA can involve hundreds of recommendations. So as you might imagine, it's not a small project. Furthermore, although not mandated at the time of the last AAA, zonal hazard analysis, or ZHA, is recognised by the MAA as an important technique for identifying and analysing credible zonal hazards, and it was used extensively to inform the aircraft safety case argument. In 2015, the Hawke T1 had not been subject to a full ZHA, but the cost and time savings and the benefits to be derived through undertaking the ZHA in conjunction with the AAA were obvious. So the two things were combined, with the ZHA being included as part of the overall AAA project. In addition, completion of the zonal hazard analysis identified potentially hazardous physical interactions between equipment within a zone and or adjacent zone, and it validated the aircraft design for potential undesirable system interactions, and validated the aircraft build manufacture standard, and to a certain extent, maintenance standards as well. So I've got a few slides here which show some of the areas that were inspected, some of the findings that were made through the AAA physical surveys. So one of the aircraft that was looked at was a RAeS aircraft, one of the older RAeS aircraft, and it probably looks extremely clean, well-maintained aircraft, considering its age and the use that they get. Looking very clean and looking very presentable, but nonetheless findings were made that are age related, as you would expect. So if I just pick out some of the perhaps the more typical examples, the middle one there on that slide, excessive corrosion on some of the structural elements, some of the bolts and some of the components that we found, perhaps to be expected, but again, not acceptable for an aircraft that's in service. So some of the findings reflected those kinds of things. Again, you can see a deformed rivet believed to be making contact with the flaps. So there's some evidence of fouling, perhaps evidence of incorrect rigging or something over the years. So again, indication there is something that needed to be obviously rectified, investigated and rectified. Evidence of historical chafing or historical contact between different components or pipework potentially. Again, all subject to investigation and rectification. And also the engine and the area around the engine was inspected for similar things. So you can see there that one of the retaining clips for a run of pipework had fractured, and that was found during the audit. And something that's fairly typical on a RAeS aircraft is the coloured dye. It gets everywhere, quite literally, and you can see on the wiring there that that's been contaminated by coloured dye, which is obviously highly undesirable. See evidence of perhaps oil and water. So something at some point has had a leak, and the oil has found its way into the various areas on the aircraft. And you can see there, again, evidence of corrosion to some of the bolts, which would need to be clearly replaced. For the EWIS, and I'll explain what that is. During my time in the Hawke TEA, Defence Science and Technology Laboratories, or DSTL, set up and funded a long-term electrical wiring interconnect system, or EWIS, which is a cradle-to-grave programme managed, coordinated and carried out at the same time, generally as a AAA, but not always. But it was managed at the time by a company called Cable Connect Solutions. Each EWIS survey considered the following potential technical failings with respect to installed wires, harnesses, clips, connectors and bonding points. They look at consistency of build standard against the design standard, look for signs of moisture ingress and corrosion in swamp areas, signs of heat damage in hot areas, whether there is adequate protection for the wiring, and things like cable, harness and loom damage for things like minimum bend, fretting, fraying or abrasion. And that's a typical scope for an EWIS. But overall, the EWIS itself identified a high volume of age-related husbandry and condition issues, most being typical of the kind seen on a 50-year-old aircraft, but very few of which were an immediate airworthiness concern, despite what you can see in the following photos. So obviously electrical connectors that are extremely dirty, probably haven't been disturbed for many, many years, but that's fairly typical of what was being found on a 45 or a 50-year-old aircraft. And there you can see how the cabling is chafing on the edge of a lightning hole. And again, probably fairly typical of an old aircraft with the dirt and the grime of many years of operation finding its way onto connectors. And probably a close-up of the earlier photo of the dye contamination on one of the RAeS aircraft. So, moving on, we'll come back to this picture later because the observant amongst you will notice that they aren't Royal Air Force Hawks, but we'll come back to that picture later on. So we've had a look at some of the challenges that sustaining an aircraft fleet of aging aircraft can cause. But what about capability sustainment? How do you keep a 50-year-old analog aircraft relevant and useful when the world around it is digital and computerized? Legislation and regulation changes demand that certain equipment upgrades are carried out. Safety recommendations from numerous service and boards of inquiry require technically challenging modifications. Societal and reputational concerns demand that technological advances in safety are incorporated on all aircraft. The time, cost and trouble required just to keep the Hawke T1 aircraft relevant is considerable, and it's not an insignificant undertaking. There are competing forces that all need to be considered. The requirement itself, so legislation, regulation, safety, capability, obsolescence, and things like that. You need to consider what is technically feasible or possible. If you think about the aircraft real estate and the architecture of the aircraft, there may be things that you would like to do to it that you simply can't because the aircraft itself doesn't make it possible. We need to consider the capacity of the organisation to deliver the volume of activity required. The size of the Air Force and the MOD is obviously much smaller these days. There are resource constraints, and that has to be taken into consideration. Of course, affordability is always going to be a question, and the proportionality of that affordability. What is a reasonable amount of money to spend on an aircraft that is already 45 years old? And of course, perhaps most importantly, the end result. When you've gone to all this time, trouble and expense, what are you left with? Do you have something that's relevant, capable, or are you just treading water to stay legal? Anyway, more on all of this at the end of the presentation, because it's actually extremely relevant to the future of the aircraft. So if we look at the modifications themselves, what needs to be done? So this photo here shows the SIF, or Successor Identification Friend or Foe, which I'm sure you're all familiar with or at least heard of. The background, as I'm sure most of you are aware, is that a SIF capability is required in order to ensure compliance with the mandated CEA secondary surveillance radar requirements, which were developed from a European Union implementing regulation. Before my time with the team, the Platform Authority approved the original proposal for 12 RAeS Hawke aircraft to be fitted with SIF 4810 as a system, which is a widely used system already installed on a number of military platforms. At the same time, an agreement to continue to operate the Hawke T1 fleet beyond the 31st of March 2009 was granted by the CAA on the basis that the MOD funded a programme, and that was in place fully by the 31st of March 2012. And this was achieved for 32 of the Black Fleet Hawke aircraft. And then a further exemption was granted by the CAA for the RAeS Hawks out till December 2018, based on the out of service date at the time, December 18 at the time being the perceived end of service life for the RAeS aircraft at that point. But of course, due to the continued uncertainty of the out of service date and the inevitable budgetary, resource and time constraints that have been applied over the last few years, the RAeS SIF embodiment was delayed due to a lack of a clear requirement. Or to put it simply, no one wanted to commit taxpayers' money to a very expensive modification until it was 100% certain that it was required, which is not unreasonable. So the Strategic Defence and Security Review in 2016 provided the long-awaited decision. However, if we couple the uncertainty of the last 5 years or so with a RAeS requirement for a solution that doesn't utilise the pannier space, and obviously that the pannier on a RAeS Hawke is used to carry the essential luggage and personal items that you need to travel around the country or the world in a Hawke. So you can't afford to give up the pannier space for the sake of a SIF modification. So that was another complexity that had to be considered for the RAeS. And against the backdrop of a rapidly evolving CAA and MAA regulatory framework, it seemed likely that the SIF capability would need to be expanded further, perhaps. So you can see why the modification was delayed for so long. Actually, lots of different factors competing, making it a very complex programme. But unfortunately, the delay resulted in the programme becoming unaffordable against original cost estimates, with ever-increasing equipment, solution development and embodiment costs. In 2020, the SIF solution for RAFAT has been technically resolved and an embodiment solution agreed. But consideration also needed to be given to blending the SIF requirements with the collision warning system and global positioning system solutions due to the interdependencies of the transponder and these systems. So delivering these systems as a whole could have real safety benefits and assist in reducing the risk of mid-air collision or MAC now and into the future. But the complexity of trying to integrate a number of interdependent systems and capabilities resulted in a number of decisions to decouple and then recouple one or more solutions, which in turn resulted in delays and increasing costs over several years. The constant possibility of the aircraft going out of service meant that cost-benefit analyses never provided a compelling financial argument for expensive technical modifications. And in 2020, I think it's fair to say the aircraft reached a tipping point where it could no longer continue to operate as a safe and relevant platform without significant investment. Collision warning system. So the imperative for fitting Hawke T1 with a collision warning system was driven from the Murray Firth tornado mid-air collision a few years ago now. During the concept phase, it was highlighted that the CWS had different Hawke project dependencies for the different potential solutions. In 2015, one proposed solution was dependent on the embodiment of the SIF modification in order to free up space to fit the processing unit. Given the problems that we've already discussed with the SIF solution, there was a reluctance to tie in the high priority CWS project with another technically and commercially complex modification. However, another proposed solution from a different supplier was dependent on the attitude heading and reference system modification embodiment. So to an extent, two of the three proposed solutions had dependencies and critical paths linked unavoidably to other projects. The third solution from another supplier was undesirable. At the time, if the GPS and CWS projects were procured separately, they would need to be sequenced, with a delay to the GPS project. Essentially, this is because of the dependency that exists between the GPS and CWS for at least one of the CWS solutions considered during the concept phase. In other words, if they were to be standalone designs, then in order to achieve integration, the CWS design would need to be completed prior to the GPS solution, in order to be able to specify the integration requirements between the systems. There was an option to look at existing systems from other aircraft, but technical challenges still existed to modify a civil certified CWS to display onto a commercial off-the-shelf GPS. And in the process, it would have potentially invalidated the system's civil certification anyway. So again, you can see the complexities with trying to develop combined solutions for multiple capabilities on a 50-year-old aircraft. So to bring this up to date, in 2021, CWS is progressing as a standalone project with a maturing technical solution that has passed preliminary design review. Affordability remains the biggest challenge against the backdrop of competing capability requirements and a marginal cost-benefit analysis with a platform out of service date of 2027 potentially. Another priority for capability sustainment is GPS, or Global Positioning System. The GPS has been in use on Hawke for 15 to 20 years. It's not a new capability, but the current system has about the same functionality as a very basic TomTom that you might use in a car. It's clunky, it's unreliable, and it requires multiple button selections to make basic inputs to the system. Now, this well-known photo from the 1980s shows a Welsh farmer who painted a message on his barn roof. It became legendary, but it's actually a true story. And of course, every fast jet pilot in the RAF went to take a look, and about a month later, he painted over it because it increased the fast jet traffic over his farm by about 1,000%. But there's photographic proof that that legendary story is true. But in the days before GPS, the aircrew would rely heavily on traditional map and compass navigation skills. But today, with modern GPS and navigation systems, we're moving more towards a paperless cockpit, as can be seen here in a Typhoon over London. Or maybe not. And the image I have in my head there is of a street map of London with an arrow that says Buckingham Palace this way. Who knows? The existing Hawke T1 SkyMap 2 GPS, as seen here on a RAeS aircraft, was installed under a service engineering modification, or CEng, and cleared in the release to service as a clearance with limited evidence. A review highlighted a number of issues with the existing system, specifically that the human-machine interface is not very effective and is very time-consuming and, well, I think a bit clunky is probably the best way to describe it, resulting in additional heads in the cockpit or heads down time. This obviously reduces situational awareness and contributes to the risk of controlled flight into terrain and mid-air collision, which are the duty holder's highest operational risks. Originally, there were two options being considered for a replacement GPS solution. Option one was to pursue a combined solution for the CWS and GPS systems, as we discussed earlier under the CWS slides a little bit earlier on. And this is important given that there would be most likely cost and operating benefits to having both systems blended into a single solution. However, building on the CWS discussion, there were some real challenges with the blended approach. Firstly, the integration of the systems into an already confined cockpit layout was not simple. And secondly, integration of the systems with each other would need to ensure that both GPS and CWS information could be transmitted on the same display. In particular, it's since been recognised that there are significant challenges simply due to the limited space within the cockpit to accomplish the pilot interfaces to both CWS and GPS systems independent of each other. And additionally, there was a need to consider that having multiple displays and warnings could add to pilot workload, requiring the pilot to scan multiple displays and respond to different alerts. and this would obviously increase the likelihood of human error through confusion, distraction, or incorrect responses to multiple displays and warnings. So let me bring this to life a little bit for you. If we look at modern traffic collision avoidance systems, or TCAS in modern airliners, a few years ago, TCAS systems may have only provided a beep or a message saying, "Warning, warning." And the pilot would have to consider the warning, comprehend what the warning was, and then take action accordingly. And this decision loop obviously takes time and therefore increases risk. So improvements were made to TCAS systems so the warning became more specific. For example, traffic, traffic. So that the pilot has the comprehension of what the warning is and can then act more quickly, reducing the time taken. More recently, TCAS systems have now been upgraded further to give the pilot a command rather than a warning. For example, pull up, which takes the pilot straight to the end of the decision loop and instructs him what he needs to do. However, this still relies on the pilot to take the correct action and react quickly whenever the TCAS system gives an instruction. This slide here is a remotely piloted air system called Icana, operated by NASA, as you can see from the photo. And Icana has taken TCAS automation to the next level with a fully autonomous sense and avoid system that calculates the best chance of conflict avoidance and initiates an aircraft maneuver in milliseconds. This particular system is aimed at proving the safety of RAeS, or remotely piloted air systems, to operate in controlled airspace alongside airliners and manned aircraft. But it's not difficult to see that a fully automated sense and avoid system would also improve response time in manned aircraft, making the decision loop that we discussed in the previous slide completely obsolete. But for Hawke, we're not there yet. So we need to be aware of the risks of introducing new systems with multiple displays or warnings that may increase workload or add to confusion in an emergency. So in 2021, the preferred GPS solution is now a standalone tablet solution brought into the cockpit as carry-on equipment with appropriate clearances to support its use. Some of the biggest challenges outstanding include glare on the canopy or windscreen during night flying and integration with mission planning software. But as with CWS, there is a viable and mature technical solution that is working its way towards embodiment on the Hawke fleet. Other modifications being considered under the Capability Sustainment Programme include upgrades to existing radio equipment, improved full coverage anti-G trousers similar to the ones worn by Typhoon pilots, cockpit voice recording capability, an automatic parachute harness water activated release system called MWAS, and as a result of the RAeS fatal accident service inquiry at RAF Valley in 2018, the feasibility of a stall warning system and changes to the command eject functionality. There are further capabilities needed to meet regulatory and legislative requirements, such as ADS-B out, for example. And it's worth bearing in mind that there are over 40 other minor modifications ongoing, which are all considered to be business as usual. So this modification here, which we'll call a trial fit, was on a RAeS aircraft. Should we say one of the pilots had a problem in flight? He was caught short on a trip, and after the engineers cleaned out the cockpit, these items were fitted as a bit of a practical joke for the next time that the pilot crewed into the aircraft. And it just made me laugh that the toilet roll fitted perfectly over the throttle handle on the left-hand side there. We call that a locally approved modification. But another safety modification that may be necessary in the future is a ground proximity or terrain warning system, or RAdALT. A Gpws RAdALT capability for Hawke T1 has been considered on a number of occasions over the last 20 years. But due primarily to the incremental OSD extensions that have been applied to the platform, the cost-benefit analyses and quantitative data has never provided a compelling business case for the embodiment of such a capability. Some background. In October 1984, a Hunter aircraft operated by FRAeS, Fleet Requirements and Air Direction Unit, suffered a fatal controlled flight into the sea accident. The Board of Inquiry recommended that a RAeS modification was subsequently embodied on the Hunter aircraft. But notwithstanding further fatal accidents and serious incidents, Board of Inquiry recommendations, the Hawke T1 has never had a terrain warning system embodied. So a GPWS provides warning to the crew of an aeroplane when the flight path is such that prompt action is required if collision with the ground or sea is to be avoided. Now, the use of GPWS has been widespread in large commercial aircraft since the late 1970s, after a series of fatal CFIT events highlighted the need for risk reduction measures to be enforced. UK CAA guidance was issued as early as September 1976, alongside guidance from the FAA and other regulatory bodies. Basic GPWS typically employs a radar or radio altimeter to provide a data feed to the system. Basic GPWS, therefore, only provides a proximity warning based on radalt data at a point in time. It will not provide advance warning of sudden changes in terrain, such as a cliff face or steeply rising ground, which may present a hazard to the intended direction of travel. Enhanced GPWS systems, therefore, are typically linked to a GPS or terrain mapping system and will provide a greater level of protection over a wider area. So eGPWS can provide some predictive capability based on direction and speed of travel, but the effectiveness of the system is only as good as the GPS or the mapping software. So again, you can see the potential for interdependency or integration between multiple modifications. Consideration of a terrain warning system for Hawke T1 began in the late 1990s after serious incidents and a fatal accident. Board of Inquiry recommended GPWS or radalt should be fitted. At the time, technical feasibility studies determined that it was feasible. Further feasibility studies were commissioned with BAE Systems in 2010, and this identified that existing solutions on export Hawke Mark 60s could feasibly be embodied onto RAF Hawke T Mark 1s, although significant cockpit changes would be needed to accommodate a radalt display. The focus at the time was on a basic GPWS to provide risk reduction to 736 NAS operations. In 2013, 736 NAS was keen to explore potential risk reduction measures for their Royal Naval Hawk operations. At the time, based on the flight profiles that 736 were flying, the risk of controlled flight into the sea was considered to be the top risk reduction priority for Royal Navy Hawk operations. Terrain warning modifications were once again brought up as a potential risk reduction measure. As described earlier, a basic GPWS has limitations. As with any design change, it will also introduce new risks, such as nuisance alerts and associated pilot distraction, which would be undesirable at low altitude or high speed. More modern systems have suffered spurious readings with laser altimeters over water or wet surfaces, and an enhanced GPWS solution would require interfacing with the GPS system, which has been developed independently. Further feasibility studies are needed, given the multiple design changes that are now ongoing or planned for Hawke T1. Cockpit architecture, human factors, and ergonomics would need to be considered in any potential future solution. So again, the challenge of designing, developing, integrating, and embodying these technical capabilities alongside multiple other systems in a 50-year-old aircraft is a considerable one. So the last modification I'll mention is the feasibility of a stall warning system, or SWS. The draft specification for the Hawke aircraft from the 4th of November 1968 stipulated desirable handling characteristics. The aircraft was a training aircraft and would be flown by relatively inexperienced pilots. It had to be self-limiting at high speed, cleared for aerobatics, stalling, and prolonged spinning, with recovery to be straightforward from these manoeuvres. It had to be capable of being flown solo from the front cockpit. The stall had to be clearly defined and with natural aerodynamic warning. Mechanical warning was only acceptable if a significant saving in costs could be realised. During development flight testing, the stall, as first experienced, occurred at a good low speed, but with very little buffet warning. One or other wing dropped suddenly and uncontrollably, though the aircraft did not depart into a spin and recovery was normal. rolling out to controlled flight, but clearly this was not acceptable. Flow visualization studies revealed that a sudden leading edge type of stall was occurring, originating at about the mid-semi span. And this was perhaps partly due to an aerodynamic concession, in that for production simplicity and hence lower cost, the trailing edge flaps had been made with constant chord and section. But they were fitted to a fairly sharply tapered wing, and so the ratio of flap chord to wing chord was at its highest at the outboard end of the flap and required too much of the flow at the local leading edge. Guided by work on the half model, the flap vane on the outer part of the flap was removed to detune it somewhat, and at the cost of some maximum lift. Although the initial separation of the flow still occurred at the same point, the flow breakdown at the stall was kept from rapidly spreading towards the outer wing by the dispositioning of a large fence. Buffet warning was obtained at the cost of a little more maximum lift by putting triangular section breaker strips on the leading edges inboard to give warning and outboard to give repeatability. And you'll see these fitted to Hawke aircraft to this day, and they're known as Toblerones for obvious reasons. And I can testify personally that they are perfectly positioned to, should we say, tear the arse out of your flying suit when you sit down to slide off the front edge of the wing. That's always a crowd pleaser at an air show. Now, clearly there was scope for much more fine-tuning and investigation of more refined stall fixes, but there was a tight deadline to meet to get the Hawke into service in 1976, and this work was left to be done on later developments. A stall warning system has never been embodied, but it does form part of the potential capability sustainment plan for the future of the aircraft. So what is the future of Hawke T1? Well, like all aspects of defence, the Hawke T1 programme is waiting on the outcome of the ongoing integrated review, or IR. So the honest answer is that we don't know. But given the complexity of the programme and the considerable time, cost and trouble that will be expended to deliver it, there's no guarantee that the Hawke T1 will survive the IR. Legislative and regulatory requirements and the safety case for the aircraft mean that doing nothing is not an option if the aircraft is to continue flying. But it also needs to be considered that the capability sustainment programme only really delivers the minimum requirements to make the aircraft relevant and compliant. It doesn't present a massive leap forward. In many ways, it is just treading water. On the flip side, there is no alternative capability to replace the aircraft. Recapitalisation is always an option, but Hawke T1 has a very limited life without the modifications offered by the capability sustainment programme. So let's go back to the Finnish Air Force. So for the observant amongst you, some of you would probably have noticed the slide earlier that showed those pictures of Finnish Air Force Hawke aircraft. Now, the Finnish Air Force has been operating a Hawke T1 variant since around about 1980. But they've invested in a glass cockpit solution for their fleet, as described here. And what this has allowed the Finnish Air Force to do is to have an aircraft that can effectively interact with the likes of the F-18 because it has similar avionics and presents a much more capable training system to work alongside the modern high-performance aircraft. So the Finnish Air Force have invested steadily over a number of years to keep the aircraft relevant and capable. And whilst this might be an appealing solution on the surface, the requirements and operating environment for the Finnish Hawks is very different to that of the Royal Navy and the Royal Air Force, so it may not be the holy grail that it perhaps appears to be. For example, the need for a collision warning system in the north of Finland is probably much less than it is flying around congested UK airspace. That said, it does show that a fundamentally different philosophy might be needed, one which is based on enhancing the capability for the future rather than just doing the minimum needed to keep the aircraft relevant and legal. And again, the T-45 Goshawk program in the US Navy is perhaps another example of that different philosophy. But ultimately, whatever the technical solution, there's no guarantee that the program could deliver the required solutions in the required timescales, even if ample funding were made available immediately. It's a wicked problem. I should stress that I've got no insider knowledge whatsoever. but I will offer an opinion. There could be benefits to retiring the Black Fleet early and diverting funding and efforts towards sustaining the Red Fleet. But even that could be questioned in a continuing COVID climate where air displays and public gatherings in the UK and overseas are not possible. What's the role of an aerobatic display team if there are no air displays? Do the Reds have a future? So whilst the future of the Hawke T1 remains uncertain, I wanted to share Wing Commander Dave Montenegro, known as Monty, his Christmas message in his role as Officer Commanding the Red Arrows, and end the talk on a positive note. So Monty says, for the first time since the team's inception, we've now moved away from the familiar wrap of the Central Flying School, and we're now parented by number 1 Group Strike Command in previous parlance. The premise for this move is down to the management and governance structure of the Hawke T Mark 1. Ultimately, the service seeks to unify the decision-making for safely continuing and aging the platform. This change has made a positive impact on engineering issues already, but also has some nuances attached which need to be carefully managed as we venture into next year. In 2021, there are 3 main objectives placed upon the team. Firstly, support the UK regional economies by flying as many displays and flypasts as we can during the summer months. A 2020 without air events means that we hope 2021 will be extra special, and I'm sure we all agree with that as aviation people. But secondly, to help the government in its post-Brexit voyage by engaging with key European nations in various guises. And then thirdly, launch the team on the largest global tour seen in over 30 years by flying 12 jets from Scampton across the Indo-Pacific and into Australia. The tour is awaiting sign-off at ministerial level and is not yet confirmed, but we hope to hear news very soon. If we're committed, then we'll aim to leave in October 2021 and display in the Middle East, throughout Asia, and make our destination the Avalon Air Show in Melbourne. Aside from our national objectives, we will also help the Australian Air Force to celebrate their centenary year. Beyond 2021, we're already planning for a move from RAF Scampton to RAF Waddington. Our present assumption is that we'll move by the end of 2022 and then continue to fly the Hawke T1 until at least 2030 or possibly longer. So you've heard it from the horse's mouth. That's from Monty as the boss of the Red Arrows, and they're hoping that the plans will be to fly the aircraft until 2030, possibly longer, which I think is very positive news. What I've got to end on here is a video which you may not have seen before, which shows Monty and the team doing what they do best. So not bad for a 50-year-old aircraft. I think despite its challenges, it's a fantastic testament to UK engineering and to UK Plc. Ladies and gents, that concludes my presentation. However, what I will say is that I promise to come back in 10 years' time to deliver another presentation entitled Keeping the Hawk Flying at 60, which will describe me as much as it does the aircraft by then. So thank you all very much for listening. Happy to take any questions.
Wow, Ross, that was superb. Would I be right in thinking that the Hawk is the last all-British built aircraft in service with the UK MOD?
I think it probably is, isn't it, at the moment? Yeah, I probably agree with that. I can't think of any others.
So any replacement's got to come from outside the country.
Well, or a future Hawk, possibly. That would be, I think, the perfect solution. I think one of the challenges, certainly for the Red Arrows, is that the Hawke T1 is very simple. It's a very easy aircraft to maintain, and the more modern aircraft, such as Hawke T2, for example, are far more complex and just require a greater amount of maintenance. And it's questionable, I think, whether the aircraft would work for the Red Arrows based on the level of support the aircraft needs. That's the beauty of the Hawke T1. Very, very simple and very easy to maintain.
Yep, I can't see any questions yet, Nigel. Are there any questions incoming? Ross, while we're waiting for that, the change from Dayglow red to all black, I presume that was to improve high visibility of the aircraft. Is that right?
Yeah, correct. So I think a number of studies were carried out to find out what the best color would be for visual, if you like, the visibility of the aircraft in flight. And I think black was considered to be the best color for that visual effect. So, you know, it's most of the training aircraft, the Tucanos were the same, were painted black because that was considered to be the best color.
Thanks. Anyone else there, Nigel?
David, the question tab is on your screen, but well, maybe on your screen. There's a question from Thomas that says, "What is the highest airframe hours in the fleet, and how close is it to the end of life?"
Crikey, great question. Thanks, Thomas. I think going back to my memory of about 5 years ago, I think we had aircraft approaching 9,000 hours, which are probably well beyond that now, I should imagine, with another 5 years of flying. But certainly some of the aircraft in 2015 operating with the Red Arrows had been in service with the Red Arrows since 1979. They still had 2 or 3 of the original aircraft, incredibly. And they were obviously getting towards the very, very top end of their, not so much the flying hours, but actually more the fatigue index, the FI. So the 165 FI was generally the limiting factor. And certainly 2 or 3 of the Red's original 1979 aircraft were right at the top end of that 165 FI and had to be managed very carefully accordingly. But yeah, fantastic little aircraft.
One anonymous questioner has asked, how relevant is the Hawk for training purposes, relevant to today's technology? I think you probably answered that within your talk.
Yeah, I think my own personal opinion is that I think we make the very best of the aircraft that we possibly can, with the fantastic people that we've got flying it, and the training that we give is world class. But I think the capability of the aircraft is probably a limiting factor now. And I think we need to be looking at how we keep the aircraft relevant with capabilities like F-35 coming online, and how we maintain Hawk as a viable training platform going up against things like the F-35 and Typhoon. That's the challenge.
We've got 2 questions from Chris Hodgkinson. The first one is this excellent lecture being recorded? And the answer, Chris, is yes. Nigel, I don't know whether you want to add on to
that. Only that the settings are set up like that, and it should be available for some time. So yes, is the answer.
Okay. Second question from Chris is replacement, ARAeS, AERALIS, question mark.
Yeah, good question, Chris. And I think there are lots of people that would love to see something like RAeS as a potential solution, another British aircraft possibly. I've seen the website and the various publicity around it. I think a lot more will become clear over the next perhaps 12 months as the integrated review delivers its verdict on the future of Hawke T1, whether that's the Black Fleet or the Red Fleet. As I say, I would like to think the Red Fleet will continue for another 10 years, possibly longer. But RAeS, as you're absolutely right, is a potential contender for a replacement in the future. All we can say is watch this space.
Well, we seem to have run out of questions. Ross, I think you're being led off very lightly tonight. But well, Ross, that brings us to the end of tonight's talk. I wanted to thank you again for one of the best talks that I've enjoyed since the branch formed in 2003. Really appreciate us giving us your time, and I've thoroughly enjoyed it. If you'd like to send me your address, there'll be some goodies in the post to you in the not too distant future. But thanks again for everything you've done for us this evening. Thanks.
It's been a pleasure. I've enjoyed it, and thanks very much to all of you for organising it. And very best of luck to the Oxford branch for the future. Let's hope COVID allows us to get back to face-to-face talks in the not too distant future. Thanks again.
Absolutely.